Hello everybody, welcome back to the channel. In this video, we are going to be covering Redis and primarily how we can utilize Redis to speed up our query time that is coming from our server. So in the redis.io landing page, you can see that it says that Redis is an open source in-memory data structure store, and it's primarily used as a database cache. Okay, so what does this mean? Well, let's begin with in-memory data store. What does in-memory mean? Well, primarily databases like Postgres, MongoDB, they have persistent data. So if the machine goes down that's running that database and then gets spinned back up, our data is not lost. And that's because it stores data in disk. However, in-memory means that it only stores it in memory. And if that data goes down, if the container or the machine that is running that in-memory database goes down, and therefore that in-memory database along with it, and then it gets spinned back up, the data within it is lost. It is completely lost. And so we never want to store data that we want to persist in an in-memory database. We want to do it in a database that persists, a database that stores its data in disk. So why in the world would we want an in-memory database in the first place? This seems very odd. Of course we want our data to persist. Well, there's very good reasons for this. And one good reason for it is caching your data. So let me explain to you what caching is through a diagram. So over here I have our server. And over here we have our database. And this is a very common server database model. Our server is going to communicate to our database and ask for data. In this case, our database contains a bunch of data that is regarding posts. So let's say we have an application that shows posts that users have made. And over here inside of our database, we have 10 posts. And now let's say that our server is asking for the post with the ID of 8. Now, if we haven't implemented any sort of index, which we won't talk about in this video, but that is a way to speed up your queries. Again, we won't talk about that here, but if we haven't implemented any sort of index, if we wanted to find the post with the ID of 8, what our database would have to do is scan through every single post one by one until it finds that associated post. So over here, we're requesting a post with the ID of 8. What our database has to do is go to this post. Does this post have an ID of 8? No. Does this post have an ID of 8? No. And then it goes here, 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 and then it finally goes here. Okay, this has an ID of 8. Okay, what is the data associated to this? Let me send this back to the server. And then the server can do whatever it is that it wants with that data. This right here, this step, the step of going through every single record inside of our database until we find something that matches the condition in our query, is known as a full body scan. And full body scans can get very expensive, especially if we have billions of records. Let's say that our database is the database that is used by Facebook, and we have a bunch of posts. Actually, we have billions of posts. Imagine going through every single one until we find the one that meets that condition. Well, that can get very, very, very slow, and that can lead to very poor customer satisfaction. So what is something that we can do? Well, we can add an index. If you don't know what indexes are, I have a video explaining what indexes are, so you could do that, and you could very well do that in this scenario. But another solution, and probably an even better solution, is to cache your data in an in-memory store. Okay, so let's talk about that. So we're going to go through this same exact step, but this time we're going to introduce Redis, which is an in-memory store. And primarily it's a key value store. So things like MongoDB or MySQL or SQL databases, they store their data in tables. MongoDB stores this data in collections. Redis is a key value store. So it has a key and it has a value. You can think of it as an object. And what's great about key value stores is if you provide it the key, it immediately finds it and returns the data associated with it. And that data is the value. So if I were to provide it with the key of post 5, it doesn't have to do a full body scan. What it will do is just go immediately to key 5 and return that data. So this is our key value store. So now let's say that we have our server and we're trying to get the data associated to the post with the ID of 8. But this time when we have Redis, what we are going to do is we are going to, instead of making a request directly to the database, what we're going to do is we're going to go to Redis and we're going to ask Redis, hey, did we make this query? And in this case, the query is post 8. So this is basically the query that we want to make, which is we want the post with the ID of 8, and we can aggregate that into a key that looks something like this. This can be whatever you choose. I think this makes the most sense. So we could go here and we can say, hey, do we have the key of post 8, which is the query for post with the ID of 8? In this case, yes, we do. So, okay, terrific. Here's the data. And we don't even have to talk to the database. And this is significantly faster. This right here, communicating to the database, let's assume that it takes us 1 second. If we didn't have to communicate with the database and we immediately talk to Redis, that might have taken us 0.1 second. That is incredibly efficient and it is a huge performance gain. So that right there is Redis. But now you may ask, okay, what if we want post 10? Well, that's fine. What we'll do here is we'll still go to Redis first. We're still going to go to Redis and we're going to ask Redis, hey, do we have a key equal to post 10? In this case, no, we don't. So Redis is going to return null or whatever. And then the server is going to be like, okay, well, that sucks, but now I have to go communicate to the database. The database will then do a full body scan and then return that data. Now, before we do anything else with that data, why don't we just store it in the in-memory database? So now what we can do is say, okay, well, post 10, and remember, it sends back some data, is going to be equal to this data. So the next time we make this request, we'll go to the Redis database. We'll say, hey, we want post 10, and it's going to send us back that data. So the first time, yes, it's going to be expensive, but any subsequent times, it's going to be a lot faster. And we're going to be learning how to actually implement what I just showed you inside of a real example. And we're going to be doing that in the next few sections. Now, the server that we are going to be using is Node. So that is the server that we're going to be doing. But Redis works for any server with any framework or language that you are implementing. So if you're using Go, Redis works for that. If you're using Ruby, Python, C++, whatever it is that you're using, there is a Redis implementation. So if you want to follow along, at the end of the day, it's relatively, the process is the same, but the code at the end might be a little bit different. All right, so that is that, and I'll see you guys in the next section. In this section, we are going to cover exactly how we can download Redis on our local machine. Now, thankfully, downloading Redis is a very quick and easy process. All we have to do is go to the official redis.io page and then click on download. And over here, you should see 3 different versions: the unstable version, the stable version, and then Docker Hub if you want to spin up a Redis image. Now, what we want to do is we want to download the most stable version. So just go ahead and press download on this. Now, once you press download on that, you should get a folder. So just move this folder in whatever directory you want this in. And then what we want to do is we want to click into this folder. And now what we want to do is, you see we have a bunch of files and executables. We want to move into the source directory. And then inside of the source directory, just dig around and you should see a bunch of executables. Let me just quickly zoom in here just so you guys can see. We see here a bunch of executables. And what we want to run is the Redis server executable. And what that's going to do is going to spin up a Redis server on a specific port on our local machine. So to execute this, all we really have to do is just double click on it. And you can see here that if you get this Redis logo, let me just quickly zoom in a little bit, you can see that, hey, we have Redis up and running. And it's running on port 6379, which is the default Redis port. Now, to test this out, what we can do is use the Redis CLI. So we can actually click on the CLI, and what we can do is we can actually test the connection by saying ping, and it's going to respond with pond. Now we can use the CLI to add data into our key value pair and then also retrieve data, but we want to do that through the server, and that is exactly what we will be doing. So we're not going to be using the CLI, but if you do ping and you get pong, then hey, you have Redis up and running. So that was quick and easy. In the next video, we're going to be setting up our application. In this section, we are going to be setting up a quick REST API using Express.js. Express.js is a very powerful framework that allows us to build Node.js RESTful APIs very easily. And in case you don't know it, it's super easy to pick up, so I wouldn't really worry about that. It really just follows the common convention that all frameworks utilize to build a RESTful API, regardless if it is Node or some other language. So let's just quickly go ahead and do that. To do that, what we will have to do is open up a VS Code in an empty directory. So I created a folder and I opened up Visual Studio Code in that directory. You can choose whatever text editor you want. The most popular by far is Visual Studio Code. So what I'm going to do is just open up the integrated terminal, and I'm just going to create a new Node application. And to do this, you can just do npm init. So we're initializing a Node application -y to skip all the questions. And over here, we should see a package.json. And what I'm going to do is I'm going to quickly just create an index.js, and I'm going to install some packages. So let me just zoom in here a little bit. And you can see here that I'm going to just install Express. And we'll install a lot more packages later. But this is the framework that we're going to be using to create a Express application. So over here, what we're going to do is very easily just const express, and we're going to require in Express. And then we want to create an Express app. So what we can do now is app is equal to Express. And we're invoking Express. And this right here is our application. This is our Express application. And so now what we have to do is listen to a specific port. So we can do app.listen, and we can listen to, let's say, port 880. And we can also have a connection over here, and we can say, we should have a comma here, not a decimal. We can say here in the callback, we can also console.log, hey, now listening on port 880. All right, that is terrific, and that is really all we need to create our REST API. Now, of course, we are going to want to create some routes as well, but let's just go ahead and test this out. So we can actually run this by going inside of our terminal and doing node index. But I highly suggest not to do this approach in development. I suggest doing nodemon index. Now, if you execute this and it says nodemon is not a command that it knows, all you have to do very easily is do npm install nodemon and then -g. If you're on Mac, you might have to append the sudo over here. But if you're not on Mac, I think that, or Mac or Linux, so if you're on Windows, I think this should be okay. And what this does is it allows us to download nodemon globally on our machine. Now, nodemon is very cool because every single time we make a change in our application, it automatically sees that change and updates the running server. Whereas if we just did node index, we would have to, once we make a change, close that server and then run it up again. We obviously don't want to do that, so we'll just do nodemon and then index. And then index is, of course, the index.js file. So we can just do nodemon, and we can see here, hey, now listening on port 880. If I add an exclamation point over here, exclamation mark rather, you can see it automatically updates. Whereas, again, if I did, let's say I did node index, and now I add more, you can see to actually realize that change and see it, I would have to close that server and open it up again. Very annoying, really don't want to do that. I'm going to rely on nodemon. So now again, if I change this back to 1 and I save it, you can see automatically updates. All right, terrific. So that is the setup. But now what we want to do is we want to connect to Redis. So how do we do that? Well, to do this, we're going to want to install another package. So we're going to install from npm Redis. And essentially all this is a way, it's a library that allows us to connect very easily from a node application to a Redis server. So let's go ahead and just install that. And now what we can do very similarly is const Redis is equal to, and we're going to require Redis. So we're going to require in Redis. And now what we are going to do is we want to connect to the Redis server that we have up and running. Remember, we have this server up and running. Now, in a real production application, we might have a container, a Redis container up and running. So we might want to use that URL. Or maybe we have spinned up a Redis instance inside of AWS or whatever, and we want to connect to that. Well, we would do that very, very easily through Redis. So we would do Redis, and then what we would do is dot create client, and then over here we'd specify the URL. Now remember, the URL is going to be here, is going to be inside of our local machine. So the URL is going to be whatever localhost 6379 is. So that's what we're going to do. We're going to specify here Redis. This is going to be common throughout. And then we're going to do :/ and then localhost, which is on the IP of 127.0.0.1. And then what port are we talking about? Well, we want the port of 6379. Now, it's actually best to get rid of this and just do const, and we say Redis URL. And then over here, we can just say Redis URL is equal to this. And then we can say over here, hey, we want to create a Redis client. Now, in order to actually interact with that Redis client, what we have to do is we have to get the client from the Redis.create client method. It returns back the client, and now we can actually use this client over here to interact with Redis. And that's what we're going to be doing in the next few sections. Now, before we do that, the last thing that we have to do, this is just a little bit of Express, so don't worry all too much about that. All we really have to do is just do an app.use, and over here we're going to say express.json. This is just a middleware that parses the rec.body. Don't worry all too much about that. It's just an Express thing. So let's go ahead, and that is pretty much it. That is the setup. In the next section, we're going to talk about how we can insert data into Redis. In this section, we are going to go about setting data into Redis. Now remember, Redis is a key value store. So if we want to set data, we have to provide the key as well as its corresponding value. So let's go about doing this right now. Now, the first thing we need to do is expose an endpoint. So I'm just going to do an app.post, and then the endpoint is just going to be /. Then over here, we have a callback that takes in the request and the response as the parameters. So now what we want to do is use this client to set data. Now this is very, very easy. Now keep in mind, again, the only way to set data is to provide the key and the value. So what we can do is extract the key and value from the rec.body. So over here we can do const, and we can say the key as well as the value, and we can extract that from the rec.body. And now what we can do is we can do const, or you know what? Let's go ahead and let's do, let's just use this client over here. So now what we can do is we can do client dot set. So here we're setting data, and then we can provide the key and the value. Now remember, it is a key value store, so it might look something like this. So this could be Redis right now, completely empty. The key, let's say that we provide a key called number, and then the value is 4. That is completely valid, and that is exactly how it will store it. So let's go about doing that right now. But what we want to do is we want to retrieve this data. Now the problem with this library is that it inherently works with callbacks, and it doesn't work with promises. So what we can do, a little bit of a trick in order to return a promise, is to use the built-in promisify function that is within Node, and that is going to be inside of the utils directory or the utils package. So what we can do now is we can do const, and let's do that right over here. We can do const, and we can get the utils, and then we can say we want to require that from utils. And then over here, what we can do is client.set is equal to utils.promisify client.set. So now when we use client.set, we can actually use async await if we wanted to, because it's always going to return a promise. So now we can do const response is equal to await. Now the reason we're doing this is because this is asynchronous. All right, cool. And now let's just do, lastly, we're going to respond with the JSON, and that is going to be the response. So let's go ahead, and we're going to go ahead and save this. If you're running NodeMon, everything should be okay. Now let's go ahead and test this out. So let's go to Postman, and that's what I'm going to be using to make HTTP requests. And I am going to be making a request to HTTP localhost 880. So that's this route right over here, and it is a post request. Now remember, we have to provide it with the key and the value. So inside of the body, go to the body and then go to JSON, and then over here just provide an object where we have a key. This key is post, and then the value is this is a cool course. So let's go ahead and execute this. And once we execute this in Redis, we should have, again, assuming this object is the database, we should have a key of post and a value of this is, or this course is cool. This course is cool. And that's it. We should get this, and we should be able to retrieve this afterwards. So let's go ahead and let's just quickly again save this, and let's execute this. So once we execute this, we get a response of OK. So once we have successfully set something into Redis, the response that we get is OK, a string of OK, and that's perfect. Now, at the end of the day, we probably don't want to return the string OK. Maybe what we can do is something like, you know, if not OK or whatever. We can do some sort of condition. But over here, I'm just returning OK. So now let's go ahead and let's get the data. So now I want to get the value where the key is post. How do we do that? Well, as you can imagine, we'll be able to do that with client.get, and I'll show you guys in the next section. In this quick section, we are going to learn all about how we can retrieve data from Redis. So far we have set data, And now we want to retrieve that data. So let's go ahead and create another endpoint. And this time this is going to be a get endpoint. And let's fix this up a little bit. And we're just going to go to slash, and then we're going to have our usual callback with rec, the request and the response as the parameters. And now what we want to do is we want to retrieve data. Now again, remember, this is a key value store. So in order to retrieve data, we have to provide the key. So let's get the key from the request body. So we're going to do rec.body, and we're going to go ahead and get this key. So now what we can do is we can do client.get, and then we can get the data that is associated with this key. But now again, this is going to return the data through a callback. I don't like that. So let's just do client.get is equal to promisify.client.get. So now what we can do is we can just simply use async and await. And over here, all we can do is just get the data, and we can say that this is the value. So we're going to do const value is equal to await client.get. And now all we have to do is just return that data. So now you can just do value. So let's go about doing this right now. So we'll go over here, and remember we already set a key value pair where the key is post and then the value is this is cool. So if we provide this, so we can go through the exact same URL, but this time a get request, and in the rec.body we provide a key of post, we should get the value of this is equal course. So if I were to make this request, you can see we get that value, and it is very, very fast. So let's go ahead and let's make a request for, I don't know, post-d, which is a key that doesn't exist in Redis. So if I were to make this request, I guess I actually did add this in Redis before. So let me add posts with 5 T's, and you can see we get null back. So if the key doesn't live in Redis, we get null back. But again, of course, we can go ahead and set this if we want to. So we can go to our post request and we can set this. And now if we were to make this get request, we would get our data back. And that's very easy. So we can get data very easily. Now in the next section, let's actually go through the scenario where we actually interact with our database and our Redis server. And if our Redis server has the data, then we are going to return that data from our Redis server. But if it doesn't, then we're going to interact with the database, get the data, and then store it into Redis. So that we're going to go through that scenario, which is a very practical scenario. So now let's start using Redis in practice and go through the scenario that I illustrated in the beginning of the crash course. Now, to do this inside of our local machines, it might be a little bit of a hassle. And the reason for this is because we have to create the data, the posts, and we also have to store those posts inside of a database, whether it's MongoDB or an SQL database. And to do that, well, again, first we have to create the posts, which is a hassle within itself. And then we also have to spin up a database inside of our local machine. And that could be, again, too much of a hassle for me. So what we're going to do instead is within our route, we are going to be making another HTTP request that is going to get a post somewhere externally. And what we're going to be doing is using the JSON placeholder API. And what this allows us to do is to get specific posts that are stored in its own database. And the database that it is using is LowDB. So this way, we're going to simulate what we are encountering in the beginning of the crash course, but we don't have to actually create the post and the database itself, because we can just make a endpoint request to this JSON placeholder, which is just a free fake API for testing and prototyping. So we can go ahead and we can use this. And let me just quickly zoom in. We are going to be making this request over here. So we're going to be making a get request, and we're going to have a slash post and then slash the post ID. So over here, this is 1. So if we make this request, we get this data back. Now, if I were to change the ID from 1 to 5, you can see that we get different data back. All right, so this is cool. This is pretty much exactly what I illustrated in the beginning. So that is what we're going to be doing. We're going to initially hit this endpoint, get the data, and then store it in Redis. So when we hit this endpoint again, then we don't have to actually go ahead and make this HTTP request. Instead, what we can do is just use the Redis data and everything is fine and dandy. All right, so let's go about doing that right now. So to do that, what we're going to do is we're going to make a GET request, and we're going to do to /posts, and then the ID is going to be dynamic. Now to provide a dynamic ID in the URL, all you have to do is just colon and then whatever you want to call it. In this case, I'm going to call it ID. And then this is going to be asynchronous, so might as well just mark it with async await. All right, so now we have our Express application. So now what we want to do is we want to get this ID from the params. So what we can do is we can do const ID is equal to rec.params. So from the request params, we want to get the ID. And now what we want to do is we want to make this HTTP request. So let's go ahead. I'm just going to copy that. We want to make this HTTP request. Now the best way to make an HTTP request in Node is to use a library called Axios, and that is exactly what we will be using. So let's just do a quick npm install Axios. And now what we can do over here is const Axios, and we can require in Axios. And so here, what we can do is const response is equal to async, and then Axios dot get, and then we inside of the get we provide this URL. So we provide this URL. Now we don't always want this to be 5. So what we're going to do instead is use the dynamic ID. So now it seems like something is wrong here. And it seems like we have, you know what, let's just, I kind of rushed through this. Let's just do it right from the beginning. So Axios.get, and for some reason we're still getting expected. I'm not sure why this syntax error is resulting. Let me just quickly double check here. It's not async, it's so async here, but then the await would be here. And then over here, of course, we're going to provide this. But again, we want the ID to be dynamic. So what we can do is we can just do template literals. And then over here, we can just say ID that we get from the param. And we can also do some validation here to make sure that the ID is an actual number. I'll leave that to you. So now we should be able to make this request. And then we should also be able to return res.json, the response, and then .data, so the response data. So let's go ahead and let's just actually make this request. So in Postman, we can go over here and we can go to localhost 880/post/1. And if we make this request, we should get this data. So we should get this data. So let's go ahead and let's make this request, and that's exactly what we get. And I want you to notice something here. Notice the time that it took to make this request. Over here on Postman, you can see that it took 200 milliseconds, so 0.2 seconds. If I were to make this request again, okay, it's a little bit shorter this time. There's always some deviation. Let's just make this request a few more times. Okay, it seems like it takes around 140 milliseconds to make this request, plus or minus 10 per se. All right, so this is how long it takes to make this request. Now this is pretty fast, to be quite frank, but we can make this significantly faster with caching, and we're going to see this now. So we're going to go through the logic that we illustrated. So if we have our data in the cache, then we don't want to make this request. So what we can do here is say, hey, we want to get the cached post. So the cached post. And the key of this is going to be something unique to the request that we're making. So in this case, I think something that is unique to the request is post slash whatever the ID is. Because no matter what, if we want to get the post with ID of 6, then should be the key. Now, if I were to get the post with ID of 7, well, we're not going to call this one. We're going to instead call this. So this right here is going to symbolize the request. So we can say here that what we want to do is, first of all, we want to get the cached post if it exists. So what we can say is client.get, and over here we can provide template literals, and we can say post dash the ID. Now, if this doesn't exist, and it won't in this case, it's not going to exist in the first case, then what it's going to return is null. So now what we can say here is if we actually do have a cached post, then we don't want to go through the HTTP request. So instead what we want to do is we want to return res.json, and we want to parse this. Now, one thing I forgot to mention is that the values are always either going to be a number or a string. We can't have an object in there. So we get back, if you want to provide a object, we're going to have to stringify it. And if you want to get it back, we have to JSON parse it. So we can say that we want to return the cached post value. So you can see here we have the cached post, and if it exists, so if the cached post exists, we're going to do a res JSON of that object. Now we're also going to return, and that the reason for returning is now we don't execute anything below this. So we don't make this HTTP request. All right, so that is cool. But in the beginning, we're never going to satisfy this condition. So once we make this request, what we want to do is we want to do a client.set where the key is post and then $ID, and the value is JSON.stringify. Remember, everything has to be a string of response data. Remember, the data we get back is an object, so we're gonna have to stringify it. And that's it. That's all we have to do. So let's go through this process right now. So I went ahead and saved this. And if I went through this process, let's change this to 5 for now. So let's go through this right now. And if you make this request, notice it takes 178 milliseconds. Now, if I were to make this request again, it takes 137 milliseconds. I'm actually a little surprised by that. I feel like it should have taken significantly, it should have been significantly faster. So let's see what we did wrong here. And it seems like we were getting some sort of error. So it says here, error, wrong number of arguments in the get command. So I wonder what is going on here. So inside of the get command, we have the wrong number of arguments. So over here, I believe this is what's wrong. So if I were to comment this out, let's see if this works. So, oh, it won't work, but let's see if we still get that error. So we still do get that error. I really don't want to pause the video to show, but I might have to just to quickly debug this. I figured out the very simple problem. This should not be client.get, it should be client.set, because we're setting data, we're not getting data. Here we're getting the data, here we're setting the data. All right, so let's go through this one more time. Hopefully this works. So we're gonna go through this request again. If I were to make this request, you can see it takes 172 milliseconds. Now, if I were to make this request again, it should go through the Redis database. And it does, and you can see how much faster that is. 5 milliseconds. That is significantly faster. So now if I were to make this request again, you can see it's really, really slow. Now, if I were to change the route to 3, I want 3, the initial request is going to take this long. And then the next request, again, extremely fast. Now, if I were to go back to 5, that is in my cache, again, that is also 5. If I were to go to 4, this one, not cached, but now it is cached. All right, cool. So that pretty much sums it up. In the next section, we're just going to quickly talk about how we can deal with our data changing. The last thing that we have to do is dealing with updates inside of Redis. Let me show you what I mean. Remember, Redis is a key value store, and it stores our data in memory. So for instance, we can have post 1, and that can be, I don't know, I like cars. So this is a perfectly valid key value store. Now, in our application, we could potentially provide the feature to edit or update your post. So it could very well be, remember this is Redis, but inside of your actual database, you could update your post to something like, I don't like cars. So now it's inside your actual database, inside of the collection, it's something like, I don't like cars. And you really don't want people to see this first post because, well, this implies that you like cars, even though what you meant to say is you don't like cars. Now remember, with our current setup, what will happen is it will always show this because post 1 is stored in Redis. So how do we deal with this kind of update? Because, well, if we update it in the database, we eventually want to get this value inside of Redis. Again, with the way we're doing things right now, we're not doing that. We're just saying, hey, is this cached? And in this case, it would be cached, but with the incorrect value, but it's going to return that incorrect value. So how can we fix this? Well, one thing we can do is when we update our database, we can also update our cache. And this is very easy. So all we have to do is within that endpoint, do a client.set of post 1 to I don't like cars. Very easy. I'm actually not going to go through that because we pretty much already did that over here. Client.set. Now another approach is to expire the data after a certain period of time. So maybe after 30 seconds or a minute, you can just completely get rid of this record. And then you would have to make that same HTTP request, but this time when we cache it, we'll cache it with the correct value. And that's the approach that we're going to be taking just so I can show you exactly how to do it with Redis. All right, so let's go do that right now. And this is going to be extremely easy. So all we have to do is when we set the value, we also have to set its expiration. So to do that, we can provide another parameter, EX, for expiration, EX, and then another parameter, the number of seconds we want to hold it in Redis before we expire it. In this case, let's do 10 seconds. Now this of course really depends on your application. If you need consistent, you need that data consistently and it's always changing, maybe you'll have lower number of seconds, but if you don't really care about it, maybe you can do something like 3600 seconds, which is an hour. But in this case, just for our example, let's do 10 seconds. So this is really all that we have to do. So now if we go over here, let's make a request for something that we've never made before. So 13. So if we were to make this request initially, of course, it's going to take around 200 milliseconds. But if I were to make this request again, very fast. And if I were to make this request again, very fast, very fast, very fast. But after 10 seconds, let's just wait that long. So 5, 4, 3, 2, 1, and hopefully that was 10 seconds. If we were to make that request again, you can see that it has expired. And now it's taking a lot longer because it's going to make that actual request. But again, now it's held there. So now you can see here, well, that was probably 10 seconds. Now if we were to make this request again, now you can see it's 3 milliseconds. And that ensures if we were to ever change the data within it, then we were going to go ahead and make that request again and have the correct data inside of our Redis store. Now, probably the best approach is to have a combination of both. Always have an expiration for your key value pairs in Redis, but also update the Redis store when you update the data. So that pretty much sums it up. I hope you guys learned a lot, and I'll see you guys in the next one.